this is because if you took a sample in front of a sewage pipe and across the river, they would be completely different results. So you want the samples to represent the entire area being dredged. Second, once the test sites are approved, the samples can be taken. And then third, they will be sent off to the lab and the results will be sent back to the Army Corps. And fourth, when they are approved, the dredging process can be continued. In the case that the test results are not approved by the Army Corps, then they must be put in a different location, which is usually fairly more expensive. So it is good news that it is approved, but if it's not, then there are different locations that have different standards. So one option is beneficial reuse, which is putting the sediment in places upland where it could be used to fill something in, and it could also be used for landfills. So once they place the trash down, they use the sediment to cover it. And then there is also beach renourishment, which is where they place the sediment on beaches if it has more of a grainy content, more like sand. And this is very beneficial because many beaches erode during storms and the sand is dragged out to sea. So it could be replenished by the sediment that's dredged. Some people are trying to turn the sediment into some form of concrete or something thicker that could be used to make some sort of pavement or covering. And this has never been done before because it's very expensive. However, when I was out doing field work, we met someone who's trying to do that for the West Haven Yacht Club that we were quarrying at. As mentioned before, environmental testing is for the purpose of protecting the environment and the ecosystems that the dredged sediment is being put in. And the lab that the samples are sent to, in order to protect these environments, test for biological, physical, and chemical factors. In terms of biological testing, there are two types of testing that can be done. First are biology labs, which are sort of uncommon in New England and they're more expensive, so they're not usually done. And what they do in these labs are look at the sediment under a microscope to look at any sort of organisms that are in there and to see if there are any invasive species that can be accidentally introduced into the new environment, which could damage the ecosystem. And then second is biological testing, which is also not commonly done because it's very expensive. But what they do in this sort of testing is they place the sediment in an environment that is set up to be like the new environment, and they place species and different types of organisms in there that would represent what the dumping site would look like, and they observe how the sediment affects that environment, and they make sure that it doesn't collapse the ecosystem or have any negative effects. In terms of physical testing, it's usually done in the same lab as the chemical testing, and what they usually do is test for grain size, so whether it's sand, silt, clay, things like that. And they often use the soil texture triangle, which is shown in the next slide. This triangle is often used to determine the composition of sediment. It has three sides, which is clay, silt, and sand. And within it, you can determine the composition of any particular sample of sediment that you have. And a word that you might notice on there is loam. This is a mixture of multiple things. It could be different percentages of clay, silt, or sand. Chemical testing is the most common form of testing done for dredging projects like the one that I observed, and the lab that it's sent to tests for metals, pollutants, and different types of chemicals that could affect the ecosystem that the sediment is being put in. These include things like phosphate and nitrogen, because if these nutrients are introduced to an ecosystem, they are eaten by algae, and this causes eutrophication, which eventually leads in a dead zone, which is a collapse of an ecosystem where life isn't able to live. While working with Coastline Consulting, I was able to go out into the field for a day and do some coring. This is a way of collecting samples for environmental testing. It can either be done off a boat or by hand. The day I went out to the field, we did it by hand. However, I have had previous experience doing it on a boat at Project Oceanology at Avery Point, Yukon. And when doing it by hand, you have a long tube with a rod extended to it, and you push it into the sediment, and as it comes up, there's a little trap that can hold it in. However, if the sediment is firm enough, you don't even need the little trap, and it just uses cohesion and adhesion to hold the mud in. And then once we pull it up, we put it into the bucket and stir it up so it represents the entire area. Also, sometimes if the sediment is firm enough, when we pull it up, you can actually see the different layers of the sediment. The first layer is more organic matter, where there's dead, decomposing leaves and other sort of nuts and just things that fell into the water. And then after that, it's the sediment that's already decomposed, which has turned into more dirt-like matter. So this is the device that we use for coring. At the far end, you can see the handles that we use to push it down into the water. And then at the closer end, you can see where we nail in the attachment that goes on the end. You could either decide to use the one with the trap or the one without it, and it sort of just depends on whether the sediment is firm enough, but we would prefer to use the one without it, because then you don't have to screw and unscrew it to dump the sediment into the bucket. Once we have pushed the coring device into the ground, we pull it up, and then you tip it upwards so the water can drain out of it before we screw the attachment off. In the area that we were sampling, we did have to use the attachment with the small trap at the end, because due to the stirring of the water and maybe previous dredging projects in the area, we weren't able to hold the sediment in the tube without the trap. Once the attachment is unscrewed, we dump it into a bucket until it's fully filled. Once the bucket is filled, we stir it up so all of the samples are mixed together and creates sort of an average of the entire area that we cored. After we stir the sediment, we put it into little jars, which are sent off to the lab. And once they're put into little jars, all the leftovers that are still in the bucket are also sent to the lab, as they're used for different purposes and different tests. Once we filled our 5-gallon bucket all the way up to the top, we also filled a 2.5-gallon bucket for someone else who's trying to repurpose the sediment if it isn't approved by the Army Corps. We repeated this process of coring and jarring at 5 different locations in the marina so that it gives the Army Corps a overall representation of the marina and if it's suitable for the dumping site and won't affect the environment. Overall, Capstone has given me the opportunity, support, and courage to put myself out there and learn more about the science field. I haven't just learned more about the environmental field, I've also learned more about what I want to do after high school and after college. With my mentor, Mark Jackson, alongside me, I've been able to explore new job opportunities and gain a hands-on experience in the environmental field. There are so many different aspects of science, including biology, chemistry, physics, and political science. And it was really neat to do some work in the environmental field because it incorporates all of it. If anyone here is considering doing a capstone project, I highly recommend it because it's allowed me to gain time management and self-discipline skills while still exploring my field of interest. Thank you for your time, and I hope you enjoyed learning about environmental testing.
Nice job, Haley.
Thank you.
Impressive. Did you say that you redid the test 5 times?
Yeah, we did them in 5 different locations in the same marina.
Oh my God. What surprised you most with the results, would you say?
I think that just sort of in general, I never really expected the experience to be like that. I thought it was more, I don't really know how to say it. It was more just hands-on and like get down, get your hands dirty. It was really fun.
Yeah, kind of like out, like in terms of like probably comparing it to the classroom, like you got to really
Yeah.
and be part of it as opposed to reading about it, which
Yeah,
is
exactly.
really awesome. And the location that we're in around Guilford is nice that it allows you to do that.
Yeah.
Did anything change with the quarantine or COVID in terms of your focus on your project, or any obstacles you can share?
It was a little bit difficult to go out and do some of the testing and find a time to do it. There were some conflictions, but I started to do some of my independent research where I went and took my own samples and tests from different places in Guilford and sort of just analyzed those myself to just get more hands-on experience.
Nice.
Yeah.
And next steps for you. Do you plan to continue any of this research? Do you have any future plans regarding it?
Yeah, I've really enjoyed sort of the job shadowing experience. So I'm looking into different hospitals and labs that I could do more job shadowing and just learn more about all the different science fields because that's what I'm looking to go into after college.
Awesome. Well,
Yeah.
you definitely have an expertise, and you already have a good playing field that you've started already. So I wish you all the best of luck. You did an excellent job, and I hope you continue your research. And at this point, I don't know if anyone that's listening has any questions. You can use the chat feature on the bottom. We'll give it a couple minutes, see if anyone has questions or comments, and then if not, we will put you back to our attendee list to listen to our next presentation.
Okay, thank you.
Welcome.